This is the screencast for section 1.1, example 7. In example 6, we looked at both algebraic and graphical ways of solving some equations. We're going to do the same thing here. As a matter of fact, the solving algebraically portion doesn't work out as nice. You have to use quadratic formula. So what I chose to do is I did that ahead of time for us. If you want to pause the screen and look at this, this is something you did in Algebra 2 over and over and over again. So go ahead, look at my work, see if you would have done the same thing. And then we're going to proceed with the pre-calculus portion of this, solving graphically. In your calculator, I told you there are two ways to solve these. You could set everything equal to 0 and find the zeros on the calculator, but then you risk making error. I'd like to type in everything originally without any work done by me. So what I do is I'll put in y1, the left side of this equation, x squared. And then in y2, I'm going to put in 10 minus 4x. And I'm going to hit zoom 6. I don't really know where to start with this yet, but zoom 6 looks good. I can see that the line from the right side of the equation, y2, intersects the parabola once here, but I know that this parabola is going to keep going up and up and up, and this line is going to keep going over and over, so they're going to intersect somewhere way, 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 way up high. So I'm going to change my y max to something that I think is really huge. I don't know. 100 would be my best guess right now. It could be 1,000. It could be 20. I don't know. Just by looking at the way that line was. Oh, look at that. So 100 was too much. I probably could have gone to 50, but I can clearly see the two intersection spots, so I'm just going to leave my window where it is. If you want to cut your y max down to 50 so you can see better, go right ahead. There's no right answer to this as long as you can see what you're looking for very clearly. Now I'm going to find my two intersections, second calc intersection. Scrolling over, enter, enter, enter. My first intersection is negative 5.74, which is good news because that is one of the answers I got when I did the algebra. Second calc intersect, going over to the other side, enter, enter, enter. The other one is 1.74. Again, more good news. So I found that my two graphical intersections, the x values that I was trying to find in the equation, did line up with the algebraic values I found, which means I probably did my work right. Again, I did the algebra for us on this problem. Go ahead and stop the screencast here and see if you would have done your algebra the same way using the quadratic formula. I'm going to work on solving graphically by putting the left side into x parentheses x plus 7, and then in y2, the right side of the equation, I'm putting in just 14. Just 14. So I'm going to zoom 6, but I know that's not going to be right because that y2 equation was y equals 14. So the y values have to go bigger than 14. I'm going to go with 20. Should be enough. I might need more to the left here. Nope, there we go. So now I can go second calc intersect, all the way on the left side, hit enter, enter, enter. I've got one of those intersections. Now on the right side, too much, too much, enter, enter, enter. There's my other intersection. Both are what I got algebraically for my two x values that are solutions, zeros, roots.